Hello, Professor. My name is Kumudini, and today I am presenting Lab 7, which simulates shell pipe behavior in C++ using pipe, fork, dupe2, and execvp functions. The goal was to write a program that takes two command line arguments, each representing a shell command, and connects them the same way the shell's pipe operator does. So the output of the first command becomes the input of the second. So let's get into the running of the program. So my program is invoked like this, where I run my lab7 / lab7, and then I have my two arguments. So this basically behaves identical to typing ps-aux and the pipe operator, and then grep-i flag with syslog. So this, when I run it directly on the shell, is what is going to be identical when I run it along with the execution of lab7 program. So each argument can be 1, 2, or 3 spaced separated tokens, and if it's more than one token, it has to be coded. So the shell treats it as a single argument entry. So now let me explain the code. Let me walk through what the code actually does step by step. So we have our lab7.cpp file inside my directory. So let me cat run it. So lab7.cpp. So here is my code. And first, we're going to discuss about parsing. So we have argv1 and argv2, which are the arguments that arrive as single strings like, ps-aux, even though they represent a command plus its flags. So I copy each into a local buffer, then use strtok, which is string token, to split on the spaces into an array of up to 3 tokens. Those tokens then get copied into the null terminator character pointer arrays, since that's the exact format execvp requires. Second is creating the pipe. So pipe fd gives me two file descriptors, fd0 and fd1. fd0 is the read end, fd1 is the write end. At this point, it's just a kernel buffer. Nothing is connected to any process yet. Third, I fork twice, because the first child represents argument 1, the producer, for example, ps-aux. Before it exits, I call dupe to fd1 standard out file number, which redirects that child's standard output to the pipe's write end. So instead of printing to the terminal, its output flows into the pipe. Then it calls execvp to actually become ps-aux. The second child represents argument 2, the consumer, grep-isyslog. I do the mirror image, dupe to fd0 standard input file number, redirects its standard input into read from the pipe, then it executes into grep. Finally, the parent process. So after forking both children, it closes both ends of the pipe. This matters not just for cleanup, because if the parent keeps a copy of the write end open, the reading child can hang forever waiting for input that never technically ends. Then the parent calls wait PID on both children, so the program doesn't exist before they're done. So let me run my program now. At the top, so I use /lab7 and I enter my arguments like this, wrapped around quotes because we are involving more than one command in each argument. And when I run this, oops, I'll have to firstly run my make. And now when I run my program, so you can see that it currently prints every process whose command line contains syslog, matching things like or syslog D and dbus daemons, syslog only flag. I compared this against running the same pipeline natively in the shell, and the real matches were identical. The only differences were cosmetic, like grep's color auto alias in my interactive shell, which my program bypasses since it's called execvp directly instead of going through the shell, because we ran it before, right? Yeah, so they look identical except for some of the differences that we discussed just now. The trickiest part of this lab for me was actually parsing the arguments correctly with strtok function. Each argument can be 1, 2, or 3 tokens. PS needed to become 2 separate strings, PS and -aux, before I could hand them to execvp. My first attempt kept producing garbage output. It took me a while to realize string token function actually modifies the string it's tokenizing in place, overriding the space delimiters with null terminators as it goes. So I couldn't call it directly on argument V of 1. I had to copy it into a local buffer first. I also mixed up the fact that string token is stateful. Only the first call passes in the string you want to tokenize. Every call after that has to pass null, or it restarts from the beginning instead of continuing where it left off. Once I understood that, it keeps its own internal position between calls and set up a while token not equal to null loop, reassigning token equal to string token null each time. The parsing logic clicked and everything downstream, building the execvp arrays, worked correctly. Overall, I would rate my understanding of this lab as strong. I can explain confidently what each system call pipe for do execvp is doing and why the order of operations matter, which I think is the real point of this lab more than just getting it to compile. I tested my program against multiple real shell pipelines and the output matched exactly. And I added error handling around every system call so failures produce a clear message instead of a silent crash. So to wrap up, this lab gave me hands-on experience with process creation, file descriptor duplication, and inter-process communication through pipes, which are the foundational concepts behind how the shell itself works. So thank you so much for watching my video.